Hello and welcome to any combo lords joining me there. Once again, we've got a stream here in my room, a live video that if you're in the future tuning in for mathematical things, comb through this video to find some cool shapes because we'll be looking at some cool new families of simple equation I was messing around with on a graphing calculator site and making some cool landscapes and shapes and interesting things in there. Now, before that, let me pull open our chat and have a little intro because part of why I am doing our stream here today is because we just passed 95,000 combo lords. Of course, as usual, somewhat of an overrated number in comparison to other large numbers. You know, it has nothing on the factorials, the highly composites, or anything of that sort. However, still in our base, anytime we hit one of those new digits, it's cool, and we're pretty close to 100,000, which will be insanely wild that we've gotten there so quick, given that right now is just approximately the 6-month anniversary of this channel. I created this channel right near the end of August, but I didn't start posting until September 1st, which, whether you're counting on half of a year's worth or on 6 months based on the day of the month, that is just about 6 months from either tomorrow or the next day. So, within 6 months, we got to 95,000. I was filming some of these shorts a little earlier than that, a few months earlier, but everything on this channel was still filmed in less than the past year. And so we're going at an awesome rate so far. And because we've been continuing to grow such a community, and people are helping me out on Patreon, and I'm getting a few ads starting to make a tiny shred of money, which I spend on combo class, but which is starting to get closer to paying for itself instead of dipping into my savings. So a good trajectory. I have, like I mentioned in a bonus video, been in the process of quitting my private lessons. And I basically have done that as of a few hours ago, which was, a big shift for me that hasn't fully sunk in yet, but has somewhat sunk in. I still have one or two little check-ins with students, like a math lesson with someone newer and some other stuff like that. But as far as some music students who I've had for many years, I had my last lessons with them today and yesterday. And that's, of course, quite emotional. And if I think about it later, I have plenty of feelings to share about that. But I will save that for a little bit later just in case I get too sappy or emotional or anything. In any case, for a brief story behind that, far before I was making combo class, I was working at a music shop. And at first I was just helping manage the music shop. I had, first, even before that, just run retail at a miniature music shop and then helped it grow and sort of managed it and then switched into a music teacher there. And I'd been making all sorts of strange book ideas, video channels that only some of you know about. Most of you don't know about my old channels, even though I've left some obvious clues around. But with those, which I will reveal when the time's right, which will be pretty soon, I was sort of separating my crazy, fun video making side and my teaching side. And I decided to try merging them just a few years ago, and it took a little while for me to actually get to the point where I started filming the current iteration of Combo Class due to some rocky times in my life. A lot of difficult, crazy stuff, but I did end up managing to begin filming Combo Class on the main channel slightly more than a year ago, the stuff for this channel less than a year ago, and all of it came out less than a year ago, with this channel being out for 6 months now. So, now that we're getting here, I went through many evolutions over that time. I was getting surgeries, so I had to take breaks from teaching all the time for these surgeries, and then would go back to teaching, And I went from, then the pandemic hit and stuff, and you had to start teaching digitally. And so I had all sorts of phases: teaching music at the shop, teaching them digitally for the shop, teaching them digitally for myself, taking a break for surgeries, going back to teaching students myself. And then I had students who I just managed myself at this point, but it was time to tell them, oh, I got to cut you loose. Hopefully, the mathematical and other types of wisdom, and I mean musical mostly for most of them, knowledge that I've given you is enough for you to continue the journey on your own or with other teachers' guidances. And I told them the link to my channels, which was kind of funny because a lot of them had no idea this was going on. Also, I had shorter hair when I met a lot of the parents and looked maybe a lot neater. And so I was like in a setting when I first met a lot of the parents, because I was teaching the kids a lot of the time. When I met the parents, I was like in a shop looking a little more professional, maybe, and way shorter hair and beard and stuff. And then when I show them this, they're like, "Whoa, this is what's been going on all the time." He looks like crazy, wild, and disheveled in his 500 clocks, but does have a lot of subscribers apparently, and so that probably surprised a lot of the families. And there's a few that I'll probably stay in touch with, because there's a few who I've known for years who, I mentioned they can still reach out. But it's time to switch, and now March is sort of a transitional point as I switch my life to being dedicated toward combo class, my books, and my music, and mostly for now, combo class as the part that I see as my job, but those other things will be woven in as well. And by combo class, I do mean both of these channels, the one called combo class and this one I'm calling Domotro, that I stuck the from combo class on, so, help newcomers know the connections. And hello to the people joining me here, to the mixed video and combo class bonus sequels. Yes, there are several bonus channel sequels. I guess the mixed video one was the original one to get that trend started off, so shout out to that one. And to all the folks who come into my streams a lot and leave comments all the time. At some point in the future, be on the lookout for, I'll mention in a stream or probably a bonus video, that I'm almost going to film some shout outs for the finale episode, and I will shout out some of the people. Mostly it's going to be for the Patreon supporters and for people who have helped me on the show, but I will also shout out some of the fans who I've seen in a million streams or comments. So I will ask for you folks to let me know if you think I'll recognize your name from a million things, and you think that I would give you a shout out for that in some future video when I'm closer to filming that finale, which is 3 episodes out. The third last episode on the main channel will be coming this Thursday in 2 days. Maybe 1 day for some of you in a much different time zone. And, I mean, obviously the amount of time from now till I drop it will be the same for you. But which day it lands on could be different. Now, that's funny. I just realized, what if your birthday was really close to the cutoff and you were like born in one time zone, but then you moved when you're an infant and lived in the other time zone your whole life? Should you go by the birthday that is when you would have been born in the time zone where you live, or does it have to be where the hospital was? In any case, someone says greetings from East Bay. If you mean East Bay, California, I am in that whole region as well. I am in the Bay Area of California, if that's what you happen to mean. And if any viewers who are from the Bay Area of California do want to find a way to help out in the show in some weird way, you can always hit me up on my email, combouniversity@gmail.com. No punctuation apart from the at and the dot that you need. That'd be funny if you try and tell someone, it's like, that's my email, no punctuation, meaning like you don't have a dash or something between the 2 words in it. But you really mean no, like literally no punctuation. I mean, combouniversity@gmail.com. No punctuation. Like, how's that gonna work? And to the first comment, sorry I went backwards, but to whoever asked if I have thought of turning my room into a green screen, so I have thought of that, but funny enough, I thought of that after I painted it. I painted it because I like the color green because it reminds me of nature, and because when I was in the paint store, this shade was called lizard green, and I thought that was particularly cool. So I was like, all right, I'm going to paint it lizard green. And then later I realized that'll make a mighty fine green screen probably. The thing is, it's bumpy on the wall. Now, if I wear the right clothes and have the right lighting, the lighting is always the hardest part with something like that. With the right lighting, it would work, but it's a little bumpier than it may look from afar, the texture. And so that will make it maybe a little harder. However, for the combo class aesthetic, I feel like a sloppy green screen could even look cool. And someone's wondering if I need any remote help. And yes, there's already a lot of people who I'm late on getting back to who have offered help, who I still need to get back in touch with and continue those processes. But I do always need help still at this point of growth. So people who want to find a way to help in some way or another can reach out to combouniversity@gmail.com. There are various tasks that could help me with the growth of Combo class. And although I wouldn't be able to pay anything for help for those now, I do like crediting people. So someone would like talk about math. And yes, to whoever's from the East Bay and was in Berkeley today, I am right around that region. And somebody would like me to talk about math, and we will be getting there quite soon, don't worry. Our transition toward math is actually going to be, we're going to look at some funny sorts of math, which were whenever I'm pulling open my stream stuff to get it set up, I have a separate browser here for what I use to like pull up in Desmos and stuff. So it's like from scratch. And whenever I pull that open, I'm like, what are the classic tabs I might want to have open for the stream or prep for the stream? You know, like my crazy graph equations, other fun stuff. And one of those has been funny bad math answers from the popular chat robot ChatGPT, which, as usual, you know, the disclaimer is, of course, it's not designed for that. However, it is comical how bad it is. It's almost like they programmed it to be more wrong than right with how it answers certain math things. And the logic it uses when generating sentences in it are just logically inconsistent of sentences, even if you didn't know math. And it's weird because it's not that inconsistent when you ask it about other subjects. I don't think people claim that they use it to write essays for them. And oh my God, if you tried to use it to write a math essay, and there are certain things that if you ask it about some historical thing, it might get it right. But if you ask it about like a number, tell me a fact about this number, your paper would be debatable whether it would be more right or wrong, because it's like half of the answers on there are wrong. Or some of the answers are wrong twice, and not in a double negative back to right way. So we are going to shrink and look at that robot for a moment. And the reason I mention that all is because I asked it to start today when I was pulling it open as a tab to be like, maybe that'd be fun. Why don't I have it tell me something interesting about that number 95,000 that we just passed? That, as I was saying, is a little overrated. Of course, as we went into in my last episode on the main channel, we can note that numbers ending in multiple zeros, although it's base dependent, and those zeros only make this number in terms of 2s and 5s composing 10s. Zeros in any base at the end of a number do imply divisibility by a perfect power when you have multiple zeros at the end. So 3 zeros at the end does automatically imply this number is divisible by a cube if it was written in any of the integer bases 2 or greater. So although it's base dependent that, oh, big deal, it's 95,000 in our base, any number of this family that's divisible by a cube might be more interesting than some of its neighbors. For fun, I did look up the first prime after it, and it's 95,003. We get a prime pretty quickly after it. So that's arguably a cooler number we just passed, depending on your standards on primeness versus divisibility by cubeness. So, it's funny, the most interesting numbers sometimes can be the ones that are the least divisible, the primes, or the ones that are the most divisible for their size. And so the ones in between with an average or medium amount of divisibility turn out to be the least interesting. Now, let's see what the robot thinks about this particular number. Well, tell me something interesting mathematically about the number 95,000. Now, to everybody who mentioned, oh, but they're going to update the ChatGPT so it's better at math. This is after the update. This is after they did an update that they said on other sites. Their message to the news and everything is it is better at math, among other things. But when I asked it in a previous chat, it told me, this was in a earlier stream. Where was this? It told me that one sec. When I asked it, you're now pretty good at math, and it gave me a really shrugging that off type of answer, trying to dodge the question. And so I asked, so you didn't get better at math, we got better at responding to me asking whether you're good at math. And they go, yes, that's correct. So according to the creators of ChatGPT, it got better at math with the update. But according to ChatGPT, it didn't get better at math. It got better at responding to people asking whether it's good at math. So, sounds accurate to me. So, 95,000. So, composite number, that is correct. It is divisible by the sum of its digits. Now, the sum of the digits is 14. Out of curiosity, I was like, all right, well, let's test it because it's probably right. But nope, it's not right. It's not divisible by 14. If you write out the digits in binary, you get this. Interestingly, this number is a palindrome, meaning it reads the same backwards and forwards. No, it doesn't. All right, the sum of the divisors is this, which is a highly... No, this is not a highly composite number. I'm almost positive. Yeah, that is not a highly composite number. And if you add up this, I'm not sure if I want to check whether that's right or not. What I did ask is, well, so they're so weird with palindromes. So I'm like, can you tell me some square numbers that just a random type of number to limit them that are palindromic and this Harshad number, which is an accurate name they're using, a term for something divisible by the sum of its digits in a base. And it's like, yes. And I didn't check all of these, but they got the palindromes right. But at least the first one, I didn't check any others. I'm assuming most of them are wrong because this is wrong. That's not divisible by 4. If anyone else in the chat wants, they can check how many of these are right. I wouldn't have high hopes because they're 0 for 1 on what I checked. So then I'm like, what is the largest palindromic number in base 10? Now, it would be pretty obvious, even if you're not a mathematician, and you were told palindromic numbers mean the digits go the same both ways, and you're asked, what's the largest? Almost anyone without even knowing math would be like, there's not a largest. You can pick any size you want and make a palindromic number of that size. There's not going to be a largest. The largest palindromic number in base 10 is this, which is also known as a billion minus 1. It's okay. This is palindromic. It doesn't have 10 digits. I don't know what's up with that. It has 9 digits. And then they say there are larger palindromic numbers in other bases, which the funny thing is, I don't even think that's necessary. I would have to check which one's actually larger in size. I don't know. In any case, they think that that's the largest palindromic in binary, and that's the largest palindromic in hexadecimal. And then they reiterate their claim. And then, so since these are rep digits, which read the same both ways, I asked, what's the largest palindromic number that isn't a rep digit in base 10? And they tell me what a rep digit is, and then they say, the largest palindromic number that's not a rep digit is this. This number reads the same forwards and back. No, it doesn't. This number is not palindromic. And they think it's the largest palindromic number that's not just one digit. However, in binary, this is the largest, also not palindromic. And then they reiterate their claim. And then I tried to trick them on one, but that one didn't work. Although they did say some nonsense here where they're like, the only ones have an odd number of digits. They're really close. 11 is an exception, but they're just like, for odd number of digits. For example, 11. Even number of digits. And then I said, what are some numbers that are cubes and only have the digit 3? They said there aren't any, but they gave this really weird reason. What's a cube number with the most amount of 3 digits in it? I love their logic on this one. The cube of the number 103, which is equal to this. A number that has... wait, let's even check. Is it even that? Okay, 1092727. No! That's not even the cube of 103. And, yeah, so it's not the cube of 103. Also, it doesn't have any 3s in it. Their logic for why this is the number with the most 3 digits in it is because you can compute it by multiplying 3 103s in it. And they say it has 3 digits that are equal to 3. Look, 3, 3, 3. That makes this the number with the most 3s in it. There'd be no way to increase 3s by this metric. Okay, so this is just such a weird system, and I don't know why they didn't go by the cube of like 333 or something. It's worth noting there's other cube numbers with 2 3s in them, like the cube of 102. Why does that have 2 3s in it? Okay. What about a square number with the most 3 digits? And what about a prime number? And they say, similar logic. The square number with the most 3 digits is 961. Because it's the square of 31. And there's, look, 3s. You got 2 3s right there. But then they say, as you can see, the square of 31 has 2 digits that are equal to 9 and 6. Now they're talking about these digits that aren't 3s, which are both 3 digits. The prime number with the most 3 digits in it is 997. To see why this is the case, it's because it's the largest one. Now they're talking about 3-digit. The prime number, they think this means the largest 3-digit one. Maybe that's what they mean here too. The largest 3-digit one, but that's definitely not what they meant here. The most amount of 3 digits in it. 3 digits that are equal to 3. All right. Tried to trick it and didn't work on these things as well. Random tricks that didn't work as well. This is funny. I asked them about, tell me about some random numbers. And they're like, here's facts about random numbers. No, something random number. They're talking about like random numbers. I'm like, no, I just meant random numbers. So yeah, that was just some fun random tangents. So that's all for the chat GPT for a moment. We're going to switch gears for a moment and get to our math shapes. And right here with this, we'll come back to the robot another time. I think it is comical how bad it is at logic and math and just the things it says that are completely wrong. This wasn't the worst of its answers this time. Just a quick little peek at how it was doing today. Post update still. In fact, seemingly maybe post another update. So, thank you, ChatGPT. We are moving on to Desmos. And I have many graphs on the side here. You can ignore for now because they are all turned off for now. As I go through relevant ones, I will explain them and note them. And what are we doing here? Well, something I like to do for fun is fiddle around with combos of different tools in equations on here to create strange landscapes. And sometimes your landscape looks like a landscape, like you get like what looks like rivers or mountains or stuff. Other times it looks like bugs or flowers or eyes or all sorts of things. And as we go through these graphs, a few things that I want you to note are, for one, we're starting with really basic ones, and then we're building to ones that I found just by playing around with different combos of these. And it's sort of a fun activity to test out some of the many possible combos you could make with some simple tools, like I use X's and Y's, I might take reciprocals, I might double up something, I might change one of them, I might use sines or tangents. Sometimes, although not in any of these yet, using a modular function, maybe I'll use a square root or an exponent. Now with those tools, all the ways you can combine them is really fun. And I've been finding such cool stuff. So I found more stuff I wanted to show. And what we will be looking at is starting very basic. And, oh yeah, what I was going to note too is what I want you to think about is the cool nature that some of these look like in humans and plants and animals and the world and nature and landscapes and such, as well as how elaborate some of these are going to be for such simple math. We can also try and imagine them in terms of what they're actually trying to represent on this grid, and that's why we're starting from really simple. What is x equals y here? Well, actually, no, let's start simpler. What is the grid? Well, we have two variables. We can map points that are a relationship of two variables. So x equals y tells me the points where those are equal. These are all the points on the graph. Pretty boring creation so far when you're familiar with the line, where it's the points where x equals y. So now here's sine functions, where you can take the sine of x, related to how, there's trigonometric functions in triangles. We can use trig functions here graphed, and they fluctuate. We can also take the tangents, which fluctuate in a quite different way. And that's if we had y normal, and we were taking the coordinates where the y coordinate was equal to some trig function of the x. We could do vice versa. That's where the x coordinate is the sine of the y coordinate. We could also combine those, and we could say, what are the points where the sine of the y coordinate is the sine of the x coordinate? And this is it. Funny enough, if we put a pi in these, we sort of get their size a little closer. If I put these both on the same side too, and I put a 0 there, and I have sine of pi y times sine of pi x is 0, I get a perfect grid on my grid. There is my grid. So that's our grid equation if you ever need one. This looks like this has more grid cells because I was zoomed in, but that is a size of 1 square lined up. So that's fun that it has lengths related to pi if you don't put pi in it. Oops. And it has lengths that get neutralized to 1 if you do put pi in it. So what if we take this further? Now, here is where our adventure begins to get quite interesting. There's already been so many landscapes we've seen in the past, and I will collect the coolest ones for some sort of video on the main channel at some point, where I compile the best ones we've found, and, you know, in better versions and such, and better explanations. And oh wow, thanks so much to whoever sent over a donation with their comment. That's super nice and helpful. As you may have heard earlier, I have just transitioned out of my other job to my combo class job, and stuff like that definitely helps. So thank you so much. And thank you to all the other comments. I just saw that flash up because it's brighter. Haven't been able to read all the comments right now, but I will get to them in a minute. For now, what I want to note is that, but thank you a lot to Tom Bax. And what I want to note right here is, what if we take, very similar to what we had before, sine of y equals sine of x, but we add on something to one of the sides. We're multiplying in a tan of x. Now, a lot of the previous families we've made, it was all sort of nested, like sine of tan of x or something. But when you multiply them side by side, it's kind of cool. We get these little islands of ovals. Now, these might look more boring compared to some graphs we've seen, but the fact that they're singular little islands gives me the idea we have a lot of potential here. I like the landscapes where you have a bunch of little creatures. I mean, the ones that are like cells interconnected, those are neat too. But I like these ones that seem a little rarer, where you get these separated little things. And so it made me wonder, you know, how can we play around with these? What happens if I stick a squared in there? Now, we've lost the creatures and made it more landscapey, but it is quite interesting. We have other sorts of little pockets here. And when it gets glitchy, that's Desmos having trouble handling these equations at certain sizes. Now, what if we, for example, change them both to tangents? Now they're lined up more in a different way. That's funny. What was the difference? Okay, yeah, those are lined up that way. These are like more lined up in a way. So if that was tan of x times tan of x, we could actually just make tan of x squared. Uh-oh, now it's cubed. But tan of x squared is sine of x, gives us these ovals. What would happen if we squared this side? Now, these are just me fiddling for a moment, but I did actually find some cool ones I want to show. It's like coils. That's interesting. Now, of course, when we get extra wild is when we throw on the inequalities. That's when we make it more or less than. Now we're seeing all the points where the square of the tan of the x-coordinate is at least as much as the square of the sine of the y-coordinate, which sounds, you know, like maybe on this one, an accurate amount of complexity for an equation, like not that complicated, but we did a little messing with it to give something cool and neat and infinite like this. It's already sort of like, whoa, this seems like extra cool and infinite compared to just a simple equation. But wait to the next twist I tried. So we had these separate before. We had sine of y, and now I'm going to do inequality mode. We're saying is less than or equal to sine of x times tan of x is what we had. Now, I decide, and this is the inequality mode. So then I decided, well, what would happen if, as you can maybe see in this lower one, maybe I'm blocking that, so I'll get rid of some of the unnecessaries. Now, as you might be able to see in this one right under this, my next idea was, well, let's try dividing these by stuff and make these reciprocal things that do interesting things. So I just substituted mild things. We put divided by x under there and divided by y under there. And look at this. Isn't that absolutely insane? That is the points. The edge, that thicker line on the edge, is the points where the sine of the x-coordinate times the tan of the x over the y-coordinate is at least as much as the sine of the y over the x-coordinate. Or, no, that was where it was equal, is the edge, and where it's at least as much is that filled-in region, the colors. Now, if we just make it equal even, it still looks cool, but with these edges, if you wondered how they were filled in, you might be like, maybe it's filled in just on one side or one wave of these. But the filled inness goes like back and forth in a super crazy way and makes them like these weird sawtoothed on and off things. So stare at this for a moment while I take a look at the comments. To me, this seems so much more elaborate than the equation. That seems like, to me, an equation that you like, for, a relative example, here's like x squared plus y squared equals 1. This is a circle. And so, in terms of just like looking at the complexity, which obviously can't tell you everything, this one right under that looks like, maybe that's 2 or 3 times as weird or complicated. Nope, it's a lot more than 2 or 3 times as weird or complicated. It's just crazy to me that imagine too, if you were trying to figure this out back in the day, which points does this hold true for? Like on paper and pencil. And you're like, okay, I think I got like this weird curvy line, and wait, there's another solution down here, and another, wait, what's this? And like tracing out this shape and being like, what's going on? Especially if you were seeing any sort of inequality. All right. Like I said, look at that for a moment. I'm going to take a brief look at the comments. I'm not able to answer all of them, but thank you so much for joining me. Super awesome. And whoever noted it's creating universes, definitely. To whoever else said they're in the Bay Area, also cool. If anyone, like I said, wants to contact me about helping out with combo class in any way, I am in the Bay Area and am open to that. So, as you know, my email, like I mentioned, is combouniversity@gmail.com. And the art pieces back there are things that friends of mine painted back in the day. Different circumstances behind each of them. I'll tell the story behind them at some point. And now let's look at one other weird one I played around with. I decided to nest it a little more and look at, we had sine of x over y is less than or equal to tan of sine of x over tan of y. And that's another crazy realm. This one looks like eyes. It's like eyes staring at you. A million eyes looking at you. Isn't that wild how it created like rows of eyes, essentially? You know how some animals put fake eyes on themselves to scare away predators, like on butterfly wings? You know, like these fake eyes to scare away predators? Maybe like the graph thinks I'm a predator and needs to scare me away from some secret graph. And so they're like putting all these eyes out to try and spook us away. Someone else said infinite soup. I can roll with that as well. So there is one more that's a slightly more mathematical bend to what I want to try here, but those are the ones that made me know, well, we're on an interesting path here. Clearing the eyes for a moment, what else can we do with this insanity? Because once I found this, I was like, all right, we're including this in the 95K stream. In fact, since I've had so many streams jokingly named after subscriber specials for random cool numbers, I didn't want to call this 95K subscriber special as the main one. So the graph's got the starring role in the title. But what happens if we change stuff here? And the first thing we can do is just add some sort of slider where when we start the slider at 1, that's the state it's currently at. And then when we change it, right now it's just multiplying right there. And, shrinks it upward and parts of it merge together. Whoa. And what if we had put the A over here as well? Well, similar. What if it had been in there instead? Whoa. All right. Some of these give weird perspective. Like if you try and like stare out of it out of the corner of your eye, imagine you're like standing in a corridor right here, and what you're in is like a cornfield or something, and there's a bunch of rows of corn or something going down the horizon. Some of these have really weird like optical things you can glitch your eyes into. Now, what if we had put an A over here? It seems like putting it on both sides wouldn't change much, but when it's nested like that, it will. So there we go. Now, a lot of these are keeping it quite similar because all we really had was a multiplier. So what if we now change some things? For example, what if this one also got an over y there? That actually ends up making it more boring. What if we swap them? And this is actually straighter and seems more boring as well, strangely. Although obviously it would be really cool if it was the first one we discovered. Compared to the curly ones, we're going to try and get back to one of those. But what if we have a y here instead of an x? That's a different variety. Now we have more curvy types of waves. That's pretty cool. Now, what if we replace some of these with tangents? Okay, that one has this angular part of it with these diagonal glitch lines. This one's interesting. And what happens if we instead had replaced this one? Ooh. So, there's lots of fun experiments we could try here. Other things that are really cool are exponents, where we can try raising something to a power. Whoa. Whoa, too much for it to handle. I hope I don't, like, cause my stream to go slower from this, because it seems like it's causing the website to go slower. Whoa. Uh-oh, that's not what I want. It's zooming in on the page, not the graph. That's weird. Okay, yeah, okay. I need to let this thing chill for a minute. This computer's gonna explode or something. It's gone super slow for a second. So, someone's wondering how crazy this could get in 3 dimensions, and it could. We could try and look at 3D graphs someday. We can also, with a slider, imagine the slider like a 3rd dimension, which would make it look even crazier. But essentially, whenever we have one variable as a slider, that's sort of like combing through cross sections of the 3rd dimension. Now, what's up to the magic fellow who's around here, who helps me out a lot on the Discord and also might help me in the future moderate some streams here as I get onto a weekly schedule, which will be coming very soon. I will be tomorrow meeting up with my main camera guy to film some stuff and discuss what schedule we'll be doing for March. And when I do that, I will also be picking 2 days of the week, like I mentioned, to be stream days. One that will be the morning for me, which is like 12 hours before this, or 10 hours before. One which will be around this time, but probably a little earlier, which is my evening. And I'm still not positive which day of the week it's going to be, but after I talk to my camera guy tomorrow, now that my schedule is opening up and I'm basically done with my private teaching and able to turn into combo mode fully, well, we're going to have at least 2 days a week of a fixed schedule, probably just 2 to start, and a bunch of random streams and stuff whenever I have extra time and a cool idea I want to show. But at least 2 that you know when they're coming each week. I also will make sure to timestamp those, as well as a lot of streams. This one, I'm not positive how detailed I'll timestamp it after, but I'll at least put sections to a degree of what chapters happened. I try and do that after streams, so if people watch part of a stream or miss the whole thing and want to later see what parts of it they might be interested in watching. If you don't have time to watch the whole 1 or 2 hour streams, I do try and put chapters in them when possible. And that's another thing I'll be able to be more focused on making happen, well, in March and April, because we are in the transitional state to me going even more full combo mode and the classroom resetting during these 3 final episodes of grade -1. Very exciting. Grade -2 is going to be crazy. I haven't told you about all the plans. Some of them have to stay surprises. So, somebody wants me to cue in the music. And if you mean the Desmos sounds that you can do, unfortunately, when there's a lot stacked vertically at the same spot, it's not going to let it happen. It only likes doing the sound for graphs that can go horizontally on part of it. And I could try, but I'm pretty sure they're not going to. Also, this is like crashed or something. This page is going 0.1 miles an hour. Okay. This equation is killing it. I need to take that squared out of the mix. Okay. Now the music is, where is that? It's somewhere in these zones. The music, here. Yeah, they don't let you do it for something super crazy like this. They'll let us do it for like y equals sine of x. We can listen to it. Wait. Oh no, that's volume. So that one's pretty normal, but if you do like y cubed is sine of x squared, and let's say x times sine of x squared, so it expands outward. Let's hear what this sounds like. Oh, it doesn't want to play this one? Is it because it's not resolved due to fine detail? No. Why doesn't it want to play this one? What about this? Let's play this one. Yeah. So we're going to start up here and we're going to listen. Whoa! That's wild. One more time only. That is wild. There's a cool little sound effect on this zone. Wait, no, not the whole thing, just this zone. There's a cool sound effect on this zone. Oh, did it slower that time, so it sounds different when you're close. Let me plug this in so our battery stays good. All right. So, one other graph thing I wanted to show before we come back and fiddle around with more random variations on this. If anyone finds any cool ones themselves they want to comment. If you find any that are easy for me to throw onto the screen, especially because they're variations of this, definitely put them in the chat. Any of them I'll consider trying, but sometimes people comment ones that are really hard to figure out what type of formatting it would look like in this, because it's hard to type it like that in a comment. But if there's one that looks similar to this that looks cool, let me know. For now, I want to say a mathematical one, which is we looked at in a previous episode on the main channel, and maybe in a stream, but 2 episodes ago on the main channel, one of the questions in part of the episode was, well, the full question of the episode was essentially which sets of numbers, and we'll say the episode led to them being positive integer solutions we were looking for, but first let's be general and say any real numbers, which sets of numbers have the same sum and product. And if we're looking at just 2 numbers, x and y, we can say xy equals x plus y and graph that. And these are the sets of solutions of numbers that sum are equal to their product. 2 and 2, got 4 and 4/3, and you got all the other solutions whose sum is equal to their product. And there's these two webs, but what if we had asked, what are the numbers where the sine of their product equals the sine of their sum? Remember those trig functions? Well, bam! Now there's a lot of solutions. Now there's solutions all on these lines, all these crazy lines. So it also looks pretty cool with an inequality. We fill in certain sectors of it. Now, what if we had done a different one? If we had asked where the sine of the... This is all the points where the sine of their product... And by points, I mean coordinate pairs. So, like, if that's the point I'm talking about, we're saying 2 and whatever numbers right there are two numbers that have this property. Sine of x times y means the sine of their product is the tan of their sum, tangent. And what if we had done tangent on both of them? And wow. So this is another fun way to take these graphs is think of a little algebraic question, sometimes even using words as opposed to algebra, like what are numbers with same sum and product? Then how do I put that in algebra? And then can I use a graph to help me look for solutions? And then can I mess with that and take what was a simple algebraic identity, which numbers have that xy equals x plus y property, and can I take that and throw in little things like sines or tangents or mods or stuff like that to create crazy landscapes. And the reason I thought of that one was because it worked so well in earlier streams, and this will maybe be part of the core topic of when I make a main channel episode about a lot of these things we've found, is distortions on the circle equation. We looked earlier at how x squared plus y squared equals 1 is the unit circle, the circle with radius 1 centered at the origin. And if we say a instead, it's basically a circle with radius square root of a. And what if we say the sine of each of them adds to that? Well, here's what it looks like. Oh, no, wait, sine. Here's what it looks like when a is 2.9 because it doesn't work up at that size. But when we slide lower, instead of it being like when you get bigger, there's one circle always, but it changes size. It's like no circles, a lot of circular things. And we start, no, don't zoom in on the page, zoom in on the graph. And we start getting this crazy landscape where let's put a to 0. And this is the base state in some ways. In other ways, you could consider 1 the base state. And this is what it looks like at 0. This crazy web that would be hidden if we didn't have the signs. If it was just x squared plus y squared equals 0, there'd be nothing because the circle would have radius 0. And then as we raise a to 1, it starts doing this mutation, and 1 looks a different state than 0. This is the state of 1. And this was one of the first graphs that when I stumbled into it, I was like, got hooked on this, finding weird using sines and tangents and x squareds and y squared type stuff, graphs on Desmos activity, because I was like, this is such a simple equation. And let's put an inequality. Let's say these are the points where the sine of the x coordinate squared plus the sine of the y coordinate squared is less than or equal to 1. Well, let's say the ones where they're at least 1, going the other way. And it's just this crazy world. And of course, we've found many other cool ones. That one's written on my wall, as well as Well, the other one that so far I felt was so crazy I had to write it on my wall for how simple it was versus the equation. I think the ones with such a crazy equation compared to their it's such a simple equation compared to how crazy their landscape is, sort of have merit as going down in history as a cool equation on their own. Because the graph could be called part of what makes them up. The relationship between two variables has a natural draw to the Cartesian coordinates here. Now, the other one that made it was sine of x times sine of y is less than or equal to sine of x over y. And this one is this landscape. Wowie zowie. In fact, this is somewhat related to the families we were doing today. It's not as far off right here, like if we had gone x over y here and gone y over x here, then we had gone tangent here, then this was pretty close to one of the other ones we saw earlier, if not the same. But there's a lot of ways you could take these strange combos. This one has strange circles brewing in it. You can almost miss those circular lines, but if you go to equals, you can see them almost better. And there's an endless amount to find here, so I will continue looking. A few people have posted graphs they've found on the Combo Class subreddit, which is awesome. Continue to do that, as well as anything you want to post there. We need more cool stuff on there. We have a lot of cool stuff on the Discord. A lot of good chatting going on there. And there'll be fun new stuff related to that in March as well. In fact, very soon, because this was like my last day of teaching today, in some ways. I have like another math student or two, little stuff like that. But a lot of the music students who I'd had for many years, their last lesson with me was yesterday or today. So, looking at some more of the comments, thank you all for joining me. And sorry I can't answer all of the ones asking about my background, because I've gone into it in other streams before. And I will make some bonus videos at some point on this channel that explain more about specific questions I get asked a lot, like which ways did I study math, or what got me first into math, things like that, because I have answered them on streams before, so I'm going to have to skip it for now, but I'll try and put it in some sort of clear bonus video at some point as well. We do also have a recommendation here, which somebody recommended x sine x to the power of 1/3. That one's kind of neat. What if we put a y in there to make it do more stuff? No, we need to say equals y there. Well, that one has like little guys on a line, ants on a log. Okay. And all right. Someone asked, did I quit my day job for YouTube? And to a degree I did, yeah. I had private students. I didn't have a huge amount through the week because I already had needed to pause on a bunch of them and ended up stopping on them when I got 2 surgeries last year. Last year was full of crazy stuff, including 2 surgeries, major ones, one in each hip. And I'll explain more about that in the finale. That will be a few episodes from now on the main channel. Which, by the way, for anyone who wants their name on a whiteboard in there, sign up for the Patreon, or I will check at some point if there's any super fans who really, really want their name on there, who think that I'd recognize your name from a million comments. I'll ask that at some point before I write it. And Yeah, so to a degree, I quit it for needing to work on physical therapy. I'd already quit some students, and I still need to do a lot of physical therapy to continue being able to walk normal and stuff. And so part of it is I quit because I still have a lot of crazy conditions with my body I'm working on that make my life difficult. And part of it was because the YouTube channels are doing really well, mostly because of the YouTube channels. And now I will have time to focus on these. And the other things that I want to dedicate my time to, although they will be somewhat connected to here, are my books that I've been writing and the music I make. So there will be music on this channel occasionally as well. If you ever see something like a music video, don't worry, it doesn't mean that's like what the channel's turning into. It's just I've made music for a long time. There will be some here and there. And there also will hopefully at some point be announcements for books that I put out. So, stay tuned for a lot of fun stuff over time, but right now what we're working on is getting those last 3 episodes of Grade -1 super crazy and cool and resetting the classroom. And for those who didn't see, the second last episode, the one I'm filming next, because I've already filmed the third last one that's coming out this Thursday, the one after that I'm going to be filming in the next few filming sessions will be a fun, very different version of a final exam for combo class grade -1. And I've never been a huge fan of tests, although I was good at them. I never thought they were super helpful for society or a great measure of intelligence or skill. However, there can be some good things about them, and I'm going to get those good things out, as well as make a fun, new, chaotic test experience. So there will be a test that you can, like, get the text to that I'll make available somehow. But there also will be an episode where I go through and explain the questions, and where we have some test type, philosophy and jokes and insanity and such. And then we'll have the finale, which will be extra wild and like a long documentary sort of about making the grade and finishing the grade. And will contain a field trip, maybe even a camping trip, by which I mean I might set up a tent in the combo classroom for fun. And